Let's integrate t to the fourth times e to the minus t dt. Well, I think we'll proceed by integration by parts. And it looks like this is going to be an integration by parts problem that takes more than one iteration. Oh, let's actually take a derivative. 4t cubed dt, and here minus e to the minus t becomes my antiderivative. So let's just see what happens here. U times v minus the integral of v du. And if I just go on and see here, I'll have a minus and a 4. So let's go on and just factor those out front. T cubed e to the minus t dt. And here I have another situation where I'm going to integrate by parts. And so I'm going to pick another u and another dv. If I was being very, very well behaved notationally, I'd call this little u1 and this little v1 so that I was using different variables. But I'm going to be cavalier and just use u and dv again. All right, so that same kind of process we went through before. I have the minus t to the fourth e to the minus t from last time, plus 4 times, and now I'm going to integrate this by parts. So minus t to the third e to the minus t, minus the integral. And here I need to go v du again, so that minus and a 3 can come out front. T squared e to the minus t dt. All right, I'm going to go ahead and distribute this 4 through so I don't forget about it later. And I have yet another integral that I can approach doing integration by parts. And I'm just going to keep choosing my u and my dv in the same kind of way where I'm thinking about the polynomial part being u and the exponential part being dv. All right. So now I feel like I'm just doing the record keeping part where all of this same stuff that's already been integrated by parts just hangs out here. Everything that I'm getting ready to integrate is being multiplied by 12. And I have u times v minus the integral of v du. And let's see, I'm going to have a 2 and a minus. I'm going to pull that out. And let's see, what's it going to leave me with? A t and an e to the minus t dt. Well, when I think like last time, I'm going to multiply this 12 through. Leaving me with just one more integral to deal with by parts at least. So one more time, a u and a dv. Approach this with integration by parts and we'll be almost all the way finished. So, again, with the kind of record keeping of it all, I have minus t to the fourth, e to the minus t, minus 4t cubed, e to the minus t, minus 12t squared, e to the minus t. But looking up here, I can barely tell that's a minus t. Plus 24, and now times this integration by parts, minus t e to the minus t, minus the integral of v du, and finally just plus e to the minus t dt. Let's distribute this 24 through. plus 24 times this antiderivative e to the minus t dt. And so I just have one more little antiderivative to worry about. So I've repeatedly used integration by parts to arrive at this moment, where I just end up with a minus 24 e to the minus t, plus an arbitrary constant. And there we have it, one nice happy antiderivative.